with our last poster interview for today, which is proposal for motor skill training considering spatial awareness and cooperative action involving third. And we have the authors to quickly go through with his work for maybe 45 seconds to 1 minute. Okay, so for this research, we're actually focusing on the training for three-hand body in VR. We want to see that if human can actually get use of this kind of unnatural shape of the body, and then if they actually able to feeling comfortable about it, then what change in their behavior that leads to this kind of improvement? So we designed a training task in VR for 30 minutes, which compose of both touching task for training the spatial awareness around the three-hand body, and a drum the fire task, which which is training for the cooperative action of the three-hand body, which as shown in the video like this, so that they will touch the user will touch the fires in order to prevent them from shrinking. And before and after the training, we have the evaluation of a bottle dragging test to see that whether they actually improve in their general performance. So for now, the result actually shows quite a positive improvement after the training, which did indicate that we have successfully conducted the skill transfer for the three-hand body and then makes them feeling more comfortable. And there's also some kind of change in their behavior. For example, like the left hand works more in shorter distance and third hand works more centrally. So for the future, we actually want to see that if there's any change in their body perception after this kind of three-hand body training. That's all for it. Thank you. Thank you very much for the clear and crystal clear explanations. And because of the time, we don't really have any time for the questions. So just make sure that dropping any questions in the Discord or Zoom or even YouTube if you have any, and we will make sure try to reach the authors for you to answer the questions. So thank you again. And now we will move on to the next demonstrations presentations.
Hello, I'm Kyoshima. I studied about investigating perception of multiple virtual hands using a state response. And I use 9 hands to, and the procedure is EMG calibration and 2 minutes reaching task about red sphere and white sphere. And after the task, I gave stimuli and answer the questionnaires. And there are great many research questions regarding the use of multiple hands. Thank you. Please, yes.
Hi. Hello everyone. I'm Ayumi Ichiko from University of Tsukuba. And here is our research investigating the effect of animal avatars on users' self-disclosure during interaction in VR steps. We propose a one-on-one communication in which the user and the interactor use animal avatars in the VR space to promote users' disclosure. Self-disclosure mean process. People reveal and oneself to the other. In this system, two users communicate and in a real space with voice call function, and during communication, users' movements are converted to animal Oh my god, that's all. This is an operation system to easily control the movement of the mid-ECG character. Um, we propose an integrated operation system that combines puppet motion capture and human body movements. Like this, arm movements of the character is controlled via the puppet's arm, and neck movements of the character is synchronized with the operator's own neck, like this. And you can move the special movements of the character. If the you can move the puppet back and forth. The with the city character and also move back and forth like this. Of course, uh, you you can also move left and right and jump. Uh, the point is, the point is that the system enables to easily control spatial movement and multiple parts of a character simultaneously so that you can represent attractive movements of a character. Thank you.
So, uh, so the uh, we developed a 20 component or factory display. So 20 component or factory display uh, is the device that uh, a factory display can reproduce various orders by blending 20 order components using order components. So order component were determined by analyzing mass spectrum data using non-negative matrix factorization method. Uh, in the device, 20 by mixing 20そうですね。factory display is used by sending command from a PC simply. That's all. The feature about our work is that so you can remap your body system between your physical movement and virtual movement immediately in real system. So as the previous research of human augmentation, I can come up with a third arm or sixth finger. And so in those research, you can attach extra arm on your body. But so the problem with those research is that operating system is made by researcher, and it cannot be edited quickly. However, in our work, you can edit your body system just by changing the circuit in real system. So for example, if you misconnect the connection circuit, you move right leg physically, and virtually your robot avatar left arm. So in this way, you can design your input and output rapidly. And also, we developed some feedback system to increase the sense of ownership. Okay, that's all.
Okay, this research is about the telepresence robot, which can convey the nonverbal information like gaze or pointing. But when using the physical robot, it needs some cost to develop or maintenance. So our proposal method is to replace the physical some body parts to AR. So どうしよう。ちょっとこうね。でもどう見せるのどうしましょう。まあ、イメージだけ。Now we can't show you, but we replace arm to AR. Yeah. This.
So we made the scented virtual environment, and like it utilized the our olfactory display, which is the machine to scent emission, and the olfactory display uses this had the advantage like the of the precise temporal control of the intensity of the odor and also the mixture ratio, and also we beside this research we did the research about the combination of scents. So we utilized the research study into this virtual environment by mixing the two different smells. And also, in order to make in order to utilize the olfactory display's advantage of temporal control of precise, um, we use the scent emission in the landscape so that like the user feel the intensity more and more when they approach the odor source. So at the same time, we combine the information of the angle of the face in the landscape in the virtual environment tracked by the head-mount display here, and so the participant will experience the distance and also the angle-based intuitive olfactory experience. Yes. Thank you. That's all.
カメラ映ってるかな大丈夫そうかな So this is the over poster and demo presentation in ICAT-EGVE. So all of the demo and presentation are very scientific and great. So thank you for listening. よいしょ